Hello, we are the Nano Nerds, a robotics team that has been together since 4th grade. We have been working for 5 years on our patent pending invention, the polystyrenator, which upcycles styrofoam into energy in a biodegradable plastic. Over the past few years, we've especially updated our invention to be even more detailed and effective. I am Advait.
I am Emily.
I am Dia.
And I am Akil. We are inspired by conservation and environmentalism, and our team's mission statement is to completely eliminate the environmental consequences of styrofoam EPS disposal.
Expanded polystyrene, commonly known as styrofoam, has become a hallmark of the throwaway society caused by the abundance of resources. It is ubiquitous due to its low price and ease of production. However, no effective solutions have been found to properly and safely dispose of styrofoam. Firstly, styrofoam is completely non-biodegradable. Instead of breaking down over time, styrofoam breaks into small pieces that pollute the environment for an indefinite period of time. This has ruinous effects on ecosystems worldwide. An estimated 80% of marine debris comes from the land where styrofoam is disposed of. Furthermore, styrofoam floats into oceans where marine animals mistake it for food and experience adverse health effects. Styrofoam cannot be recycled either because it is not cost effective. The result of our investigation is a patent pending design for an 11-step machine called the polystyrenator. Using the bacteria Pseudomonas botida, the polystyrene converts styrofoam into the biodegradable plastic PHA and methane, which can be used for electricity production. PHA is a valuable thermoplastic which has applications in the medical and 3D printing industries. The polystyrenator can be implemented in landfills worldwide, utilizing biogas systems already in place. Our invention efficiently solves the problem of styrofoam pollution caused by resource abundance by transforming styrofoam into PHA, a plastic of better environmental value and safety.
Our invention is an 11-step machine that operates in 4 stages. The 4 main steps of our system are 1. Acetone reacts with the styrofoam to release air and decreases its volume, as styrofoam is 95% air. Afterwards, this chamber is heated to 60 degrees to evaporate the acetone, leaving behind processed styrofoam. 2. Pyrolysis, a process which breaks down polystyrene down to its monomer styrene, is used to convert polystyrene to styrene oil. The styrofoam will be heated to 390 degrees under the presence of silica alumina, a catalyst. Methane is produced during this step, which can be used by biogas reactors for electricity production. 3. Distillation purifies the impure styrene oil by heating this chamber to 145 degrees Celsius and allowing the extraneous materials to be purged. 4. The KT2440 strain of P. petita consumes styrene oil and converts it into PHA. The PHA is released through a controlled autolysis. The conversion of styrofoam due to styrene oil can easily be done in under 24 hours, and our system works continuously. Our full 11-step designs are highly specific and are attached in our presentation. Because we distill the styrene oil, the styrofoam does not have to be cleaned when putting it into the system, making our invention extremely innovative. This is because current styrofoam recycling requires the styrofoam to go through an expensive cleaning process.
Our invention is made to be implemented in a landfill with methane utilization technology to reduce electricity. Additionally, we have a complete prototyping timeline planned with the Western Placer County Waste Management Authority. We will begin prototyping with the acetone stage and then test each remaining part separately. Our designs for the invention have been reviewed by the representatives of Jacobs Engineering, Synergy, and the Biogas Corporation, working through the Waste Management Authority. Additionally, they have allocated pilot-scale funding to our project and given us access to machinery, including a pyrolysis machine, which we will need as part of the Waste Action Plan. Pyrolysis testing is scheduled to begin early next year.
We have conducted extensive scientific and technical research to create our invention. We consulted research journals and professionals such as the owners of the local Kiefer landfill and representatives from the Placer County Waste Management Authority.
To summarize, our invention is a system which takes the styrofoam and creates PHA and methane, which is then used for electricity production in the landfill. PHA is a biodegradable thermoplastic that is synthesized by many different types of bacteria. Since it is biodegradable, PHA is very eco-friendly. The PHA produced from the digester could be sold to the medical, construction, and growing 3D printing industries. For example, in the 3D printing industry, PHA is used to make PLA or PHA filament. Now on to the financials. The sale of the polystyrenator system would be highly profitable due to how much revenue can be gained through the sale of PHA for the owner of the polystyrenator. Results from a study from the University College Dublin in Ireland have found that for every 64 grams of styrene oil fed completely to P. petita bacteria, 1.6 grams get stored as PHA. For a system the scale of small digesters currently found in landfills, we've calculated that the owner of the digester will make $374 per day from the sale of PHA alone. This adds up to $11,379 per month and $136,423 per year. The price that we will sell the polystyrenator will vary based on the size of implementation, and these profits will also cover maintenance, staff, and manufacturing costs.
Our cost analysis with our materials list shows that the landfill scale polystyrenator would cost around $50,000 to implement. We got this figure after referencing the cost of the equipment needed for our invention. However, for our prototype invention, all costs would be covered by funding allocated to the Placer County Waste Management Facility.
Our invention is the only one in its class. There are no other products currently in the market that not only upcycle unclean styrofoam, but do it in a cost-effective manner. Our multinational patent analysis found that similar products in the category include recyclers, granulators, and styrofoam alternatives. However, none of them are cost-effective or inexpensive enough to warrant any usage in the market. The problem is, styrofoam is too inexpensive for people to stop using, and too inexpensive to recycle, so the only way to solve this problem is to upcycle styrofoam.
So, to conclude, we have developed a completely innovative 11-step bioreactor that converts styrofoam to PHA and electricity. Our invention has the potential to prevent styrofoam pollution in our cities and beautify our neighborhoods. It has the ability to save animals from ingesting styrofoam and to prevent styrofoam from entering the ocean. And it has the ability to produce electricity in a highly profitable biodegradable plastic that can benefit our industries. We are very grateful to the Conrad organization for providing us with so many resources. Our invention could benefit greatly if we are chosen to be Pete Conrad Scholars. If chosen, we will have the ability to expand our networking with scientists and professionals and benefit from market assessment and potential patent resources. For these reasons, we hope to be considered for the honor of being Pete Conrad Scholars. Thank you.